Images. The image tag turned 25 in fall of 2020. That's a lot of pictures. What started off as an experiment to add inline images onto a web page progressed to a very consequential resource onto the web. It both engages users with delight and enrages developers. Well, more like dislike. Image management is hard. We know that images can affect your core web vitals, and as Tim said, it can really mess up your perf analysis. Now, Addy Osmani wrote a comprehensive book covering all things images in 2020, or 2021, pardon me. Things are crazy these days. But here to talk about what makes a perfect picture is Addy Osmani with Picture Perfect. Enjoy.
Hey folks, my name is Addy Osmani. I'm an engineering manager working on the Chrome web browser, and today I'm going to try helping you load and render your pictures as close to perfect as possible on the web. No promises, but we'll see how far we get. I've been working on a book on this topic for a number of years now, which we just published with Smashing Magazine. So if you end up checking it out, thank you for your support. No obligation at all. But today I'll try covering some of the highlights. And one of the reasons why I actually wrote this book was that whenever I would try to optimize my images over the last decade, I'd start off as an optimistic corgi. Several hours later, I'd feel like I was drowning in several NPM installs and custom scripts. And I want to try helping folks avoid that situation as much as possible. So let's talk about images. Images have been a key part of the web for decades. Our brains interpret images a lot faster than we do text, which is one of the reasons why having high-quality visuals can help drive conversions and user engagement. Image optimization is a pretty evolving topic. You can take a look at a book from 10 years ago, and you'll see that it's quite different to what we have today. I often rely on image CDNs these days just because there is so much tooling involved in getting modern formats and approaches set up. But one of the good pieces of news is that browsers have been working hard over the last couple of years to help out here. Now, there have been some major changes in the image landscape over the last year alone. We now have WebP support available in all modern browsers. AVIF support is landing in Chrome and in Firefox. JPEG XL decoding is behind a flag in Chrome. And across the board, we've seen some nice improvements in the ability to refine how you load images, whether it's lazy loading them, now default in WordPress, something available in most modern browsers. Support for preload, so that you can push how early key images that might be contending with other resources load in the browser. And just generally lots of improvements to how we size images, aspect ratio, and so on. I'll try to cover some of these ideas in today's talk. Now, the humble image element has also gained some superpowers over the last couple of years. Just think about how many times we would rely on a JavaScript library or a plugin to ship an advanced image loading experience. Well, today's browsers are actually pretty capable of doing a reasonable job. You set your width and height on an image tag, and you can, avoid layout shifts. You can use the loading attribute to lazy load those images, the decoding attribute to control async decoding, and you can even set inline image placeholders, whether they're blurry placeholders or color placeholders, and you can do that just using a background image on the style tag for the image tag. So there's a lot more that you can do here. I think that it'd probably be useful actually for us to keep talking about images a little bit more and maybe even dive into some neuroscience. Ooh. Now, if you think about how large a part images play in our experience on the web today, whether it's hero images, landing pages, product photos, they're a pretty key part of our experience. And some of this comes down to our brains just being well wired up for visual processing. So 50% of the brain is involved in visual processing, and only takes 1/10 of a second to get a sense of a visual scene. Now you might be wondering, is an image worth 1,000 words? Well, 80% of how much we recall is what we see or we do, while only 20% is what we read. And so there's just so much data here that talks about the value of using imagery and using visuals to convey information. As a side note, I also read some stats that said that mentioning cognitive neuroscience makes people more inclined to believe what they're reading. So this slide has totally justified itself already. Now, how we load images on the web comes in all shapes and sizes. To be effective, all images need to be carefully orchestrated to appear on the screen fast, but as it turns out, loading images efficiently at scale isn't really, just a project for a quiet afternoon. There are all sorts of ways you can handle this, whether it's just loading the images straight up, using a fallback color to give the user a sense of what the image will be, progressive rendering, using blur hash or other blurry placeholder type approaches. Now, in many modern web experiences, images tend to be the largest visible element when a page completes loading. And these include hero images, images from carousels, stories, banners. As we're talking about things like the Web Vitals, the Web Vitals, as a quick reminder, is an initiative from Google. It's a set of quality metrics that try to convey aspects of user experience that are important to optimize for all sorts of different websites. And often images tend to be your largest contentful paint element. So worth optimizing, certainly. Images are also important from a perspective of trying to avoid them, causing layout shifts if you haven't remembered to set dimensions on them or their containers. And images can also impact things like first input delay, because if you have any resource contention in your page with other key resources like JavaScript or CSS, they can have an impact. Now, here's a kind of the money slide, but if you were trying to optimize image serving for Web Vitals, here is the list of things that I would do today. For a fast, largest contentful paint, try to request your key hero image early. You can do that in a number of ways. If you've got resource contention, preload is worth taking a look at. Use the picture element, srcset, efficient modern formats. Try to avoid wasting pixels, compress those images well, and don't serve overly high DPR images. We'll get into that a little bit later. Lazy load anything off screen. If it's not counting towards content the user is going to see in their initial viewport, maybe it can be lazy loaded. And then for a low cumulative layout shift, set dimensions on your images, use CSS aspect ratio or aspect ratio boxes to reserve space. And avoid images causing network contention for other resources, as I was just saying. Now, if you're wondering where to start with detecting what is your largest contentful paint element, take a look at Lighthouse. So Lighthouse has got an audit that will help identify what elements or what image corresponds to your LCP element. Also worth heavily paying attention to the largest contentful paint API when it comes to your field or RUM data. User devices can have different screen resolutions, they can have personalization involved, different elements that can ultimately mean that different users may in fact have a different LCP element. And so it's worth paying attention to your field data just to get this more refined, nuanced picture of what is your LCP, just in case there are multiple things that require optimization. Now, Lighthouse will also highlight if you have images that could be served in a more modern format or could be more efficiently encoded. And so if you're just using JPEGs or PNGs today, it'll highlight if you could be using WebP. On the Lighthouse side, we're also taking a look at evolving that to better factor in things like AVIF and JPEG XL. So how do you go about serving modern image formats? Well, art direction is something that allows us to serve different images depending on a user's display. And the browser can choose which image format to display using the picture element. So picture supports multiple source elements as well as a single image element, which is basically your fallback. And this allows us to serve all kinds of formats. We can serve JPEG XL, AVIF, WebP. And in this example, the browser will begin to parse the sources and will stop once it's found the first supported match. And if no match is found at all, it will use that fallback instead. Now, how do you go about picking an image format? Well, there's a lot of different aspects to this. I'm a big fan of this particular table and this write-up that John Snares over at Cloudinary did about how to reason about modern formats. Basically, JPEG was created for lossy compression of photos, PNG for lossless compression. WebP was designed many years ago now to replace JPEG and PNG. It does beat them on compression by a narrow amount. And then more modern formats like Hike and AVIF are able to handle lossy compression of photos much more effectively than JPEG. But JPEG XL then beats both JPEG and PNG in compression as well. So it is valuable, taking a look at image formats and evaluating which ones make the most sense to you. Malta Ubel has got a really great blog post looking at what quality settings to pick for modern formats like AVIF, like WebP, when you're trying to use them as alternatives for serving JPEG on the web. Now, the goal of one of the blog posts he wrote was to find out the quality setting that would create images that look just as good as the JPEG, but with a smaller size to optimize page load times without sacrificing on image quality. And so what we can see here is that there's a 54% size reduction for AVIF 70 compared to JPEG 80, or a 26% size reduction for WebP compared to JPEG. Now, when lossy compression is good enough, but both AVIF and JPEG XL deliver significantly better results than the existing web codecs, including WebP, and I would check out, again, John's blog post on this topic. It's pretty great. He uses an example where there's an original 1.7 megabyte image that includes a sky background, like a sunset. And we wonder, like, how much can we actually get out of 70 kilobytes if we were to try out different formats? If we start off with the JPEG, what we can see if we zoom in is a lot of banding artifacts on the sky. We can see lots of different artifacts around the buildings as well, which look suboptimal. We try out our WebP and we see, a slightly better quality image. I can still personally make out some banding artifacts, but it is a little bit better. We took a look at Hike, we look at AVIF. I'm very hard pressed to find, the major differences compared to the original. And as a rule, we can take a look at JPEG XL as well, which is like fantastic. But as a rule, AVIF takes the lead in low fidelity, high appeal compression, whilst JPEG XL will excel in medium to high fidelity. But they're both worth checking out. Another dimension when you're picking out an image format is to pay attention to the speed. Now, speed is something where you really want to pay attention to both encode speed, but for your users, in particular, decode speeds. Typically, older formats like JPEG or PNG don't take a long time to encode or decode. Newer codecs do compress better, but this often comes at a cost and complexity and can take a little bit longer when it comes to encoding things. So do compare encode and decode times. Sometimes those encode times are mostly going to hit you, whether it's at an infrastructure level or a build time level, whereas those decode speeds are what you're going to want to pay attention to for your users. Now, what tooling should you use for generating modern image formats? As I mentioned, I personally heavily rely on image CDNs these days. I love being able to just tweak the image format by changing parameters around, or tweak like what size gets served down or quality, changing parameters. It's also worth paying attention to other tools. So for one-offs, I personally use Squoosh.app, which is a free open source web tool. It supports a lot of the formats that I talked about today. For kind of node tooling, or if you want to roll your own, custom image CDN, you can pay attention to things like image min or thumbor. And then on desktop, things like image optim and XN convert are pretty fantastic. For debugging image formats, this is a place where DevTools can help. So DevTools allows you to disable different modern image formats from being served. So AVIF, JPEG XL, and WebP. Now, this is helpful when you're trying to determine whether the right image is being served down in your local debugging experience. So this is available in Canary. Go check it out. Now, sizing is another area that we have to think about when it comes to image optimization. And Lighthouse also has an audit for making sure that you're properly sizing your images. Now, if you're wondering why we would size our images properly, it's not just to make sure we're sizing something with, without, sending unnecessary pixels down, but we also want to make sure we're serving something that isn't going to cause layout shift. So here is a blog article, basically, where we're loading in text. When the images snap in, these don't have dimensions on them, and they push the text down, which is kind of a suboptimal user experience. So ideally, if we set our dimensions there, the browser would know to reserve enough space for these images. If you're looking for opportunities to set those dimensions on images to reduce layout shift, Lighthouse does have an audit that will call out images that don't have explicit width or height. And in the field, you can also take advantage of Performance Observer to discover, what are elements, what are images that don't necessarily have dimension set and maybe causing layout shifts. Generally, there are lots of factors that determine the best image size. So screen size and resolution, viewport, layout, your device pixel ratio, art direction. All of these things are worth keeping in mind. And you might be familiar with, the way that we've done this for a few years, basically using responsive images, relying on source set and sizes. So source set defines a set of images the browsers can select from, as well as the size of the image. And generally, each image string here is separated by a comma and includes a source file name, a space, and then the image's intrinsic width specified in pixels, or a pixel density descriptor, and here's kind of what they look like, generally speaking. An optimization I see a number of sites trying out over at the moment is DPR capping. So rather than serving 10 or 15 different variants of your image files in your source set, take advantage of the fact that the human eye may not be capable of distinguishing the difference between images that are 2x or 3x DPR versus an even higher resolution. So Twitter is one such site that uses this optimization. They basically limit image pixel density to less than or equal to 2x. And they noticed no distinguishable difference to the human eye in their tests, but it did result in a 33% decrease in image size. So this is an optimization worth considering experimenting with. I mentioned aspect ratio earlier. So sometimes you'll be building out card UI or other UI that's responsive and has images in place. The traditional way to reserve space for images is to use the vertical padding trick, which looks a little bit like this first example where we're relying on padding top in a particular equation. The modern and simpler way to do this is to define a width and height aspect ratio by defining the width and height attributes on your images and videos. And then the browser has got this equation that it will use to map the aspect ratio for you. And in the future, you'll also be able to explicitly set the aspect ratio in your CSS code using the aspect ratio CSS code rule at the very end here for the 16/9. Now, tooling in DevTools for debugging these types of scenarios has also been getting better. And so Chrome DevTools now has an enhanced preview that will show you your file size, your rendered aspect ratio, intrinsic size, intrinsic aspect ratio, as well as the current source being shown on screen. So if you hover over any image, it will show you this. And I've personally found this really valuable when debugging my image loading strategy. Lazy loading is something we mentioned earlier. So Lighthouse does also have an audit that will call out images that are off screen and could potentially benefit from you lazy loading them to improve overall performance. Now, in a page that's using eager image fetching, so basically loading all of your images up front, you can land in a situation where there's this waterfall of images that can't be seen by the user, but which are still loaded up front. And in this example, we're loading well over 1 megabyte worth of images when only a few of them can be seen by the user. If we take advantage of lazy loading, we can improve that. So using the loading attribute on the image element, we can control the behavior of image loading. And if you set loading equals lazy, we can lazy load images, deferring their loading until they reach a calculated distance from the viewport. Loading equals eager will load images right away, regardless of their visibility. And lazy is the one that we're mostly interested in right now. This can also work with responsive images. So in responsive images, when you're using the picture element, it's the image tag that's the one that's driving image loading. So as long as you set loading equals lazy on image, this should still work within picture as well. Now we can take a look at the before and after. So here's the after. Instead of loading 1.1 megabytes of images eagerly, we're only loading in 97 kilobytes of images right now. We're loading in kind of the initial images the user sees, as well as just a few of them that are present outside of the initial viewport, so that as they scroll, they're able to start seeing additional images, and then we'll fetch additional ones as the user keeps scrolling down. Now, I mentioned preload and the importance of resource loading orchestration a little bit earlier. As a lot of folks are building modern experiences heavily relying on JavaScript, whether you're using React, Next.js, other frameworks, you can sometimes end up in a place where you are using a component in your single page application that is requesting an image. But overall, if you're building an SPA and you're relying on JavaScript for your components, there could be a sequence of JavaScript files that needs to be fetched, parsed, compiled, and executed before your image can even be discovered. Now, one thing you can do is try to shift those request chains in such a way that your LCP image can be discovered by the browser much sooner. And preload is just one way of approaching this. So this is an actual app. This is a React Movie app where I was able to use preload to improve how soon users can see that hero image. And Lighthouse does have an audit for letting you know opportunities to preload your LCP image, so you can check that out. But effectively, we use link rel equals preload to achieve this. So link rel preload can be used with image to allow browsers to discover your critical resources as soon as possible, prior to them necessarily being found in your HTML. And this can, boost how soon late discovered hero images such as those that are being loaded in via JavaScript or background hero images in CSS are fetched. Preload works with just raw images. It works with different image formats such as WebP, as we see here. You can also pair it up with your responsive image loading approach, and Yoav Weiss has got a great article about this on web.dev. But preloading is relatively flexible. I will say, as a general note, use preload sparingly. Always measure its impact in production. You want to avoid getting to a place where you are optimizing for LCP at the cost of FCP, First Contentful Paint, or other metrics. So just keep an eye on how you're using preload. And the final optimization we'll take a quick look at is blurry placeholders. Now, the jury is out on whether ultimately all users prefer this experience, but a lot of sites like to try this idea of approximating what the final image is going to be before it loads in. There are a variety of modern solutions for image placeholders, so CSS background color, low-quality image placeholders, SVG-based image placeholders, blur hash, potrace. But which approach makes the most sense for your user experience might ultimately depend on what you're attempting to offer a preview of. Some people just want to show a solid color. Some want to show something that's a relatively good approximation of the final image. But there's a lot of approaches available to you. The one tip I wanted to give you here was that, again, without relying on a JavaScript solution, you can just use CSS styles, inline styles, and a background image to define a placeholder image. And this can be an approximate for the final image that you're displaying. Just keep in mind that where the core web vitals are concerned, this is an area where we're still trying to figure out what the right solution is longer term. And there are good active conversations happening around trying to factor in progressive loading for modern formats like JPEG XL into Largest Contentful Paint. Worth keeping an eye on. Now at this point, you might feel a little bit like this. You might feel overwhelmed. There's a lot involved in optimally loading and rendering images today. Hopefully you're still feeling a little bit head above water. But I did want to say you can conquer this. One of the things we've been trying to do is, beyond just making it possible to load images optimally, you can also rely on abstractions a little bit to take care of some of these problems for you. And this is an example where in Chrome, we've been collaborating with modern frameworks like Next.js on trying to abstract away a lot of these ideas so that you can take advantage of them with low friction. So from everything from automatic srcets for your images to automatic lazy loading, generating responsive images, and so on. The Next.js image component is a new component which can improve your Largest Contentful Paint by up to 60% and reduce CLS by up to 100%. And the way that this works is basically without Next.js image, generally people will just use raw image tags. And this looks about the way that you'd expect it. You just set your height and width and your source. Without doing any additional work, this isn't all that optimal. In one test page that I was using for a lot of the same images as I've shown you in this talk, we were loading in 8.4 megabytes worth of images, even for things that were off screen. So that's not great. Instead, if you take a look at the next image component, which really just requires you to replace img with image and import in the image component itself, we can get quite a bit further than that. For that same page as I was showing you earlier, we can end up with anything between kind of 33 kilobytes to 80 kilobytes for our initial page load. A lot more optimal than we were initially seeing. And it does all sorts of other things. So like in an experience where I might have a ton of images below the fold, I can scroll down and it will lazy load them for me too. Now you might be wondering, is all of this worth the effort? And for the Core Web Vitals, what I'm seeing from a lot of sites is that the answer is actually yes. Vodafone saw that investing in LCP resulted in not just a 31% improvement in LCP itself, but it increased sales by 8%. And a lot of that came from image-related optimizations. Agrify saw that a 70% improvement in LCP correlated with a 76% reduction in load abandonment. Yahoo! Optimizing CLS, a lot of it related to images again, increased their news page views per session by 15%. And then Chloe, a French fashion house, saw that by preloading their 1x and 2x hero images that were previously bottlenecked on render blocking scripts, improved their LCP by 500 milliseconds based on Chrome User Experience Report data. So across the board, a lot of people are seeing that investing in image optimizations related to Largest Contentful Paint can be worthwhile. And yeah, I hope you found some of this useful. For more information, do check out the book. Check out web.dev as well. Hopefully we can get you into a place of feeling like an optimistic corgi once again. Thank you, and I'm happy to answer any questions that you might have. Cheers.